So in this video, we're going to solve two absolute value equations, one that has a solution and one that doesn't have a solution. So in the previous video, we looked at the idea that if the absolute value of an algebraic expression was equal to a positive real number k, then we can break that into two separate pieces, both of which are true. So the general technique for solving an absolute value equality is to first isolate the absolute value symbol and then break it into the two equations that it generates. So we're going to completely rewrite the problem. And then we're going to work on isolating the absolute value symbol. So step one will be to add 4 to both sides. So negative 14 plus 4 will be negative 10. Negative 4 plus 4 will be 0, which will leave us with just negative 2 times the absolute value of y plus 3. The absolute value sign is not isolated yet because it's got a multiplier of negative 2 in front of it, kind of like a coefficient. So we're going to divide both sides by negative 2. So negative 10 divided by negative 2 is 5. And here we get negative 2 divided by negative 2 is 1. And 1 times the absolute value is the absolute value. And now the absolute value is completely isolated, and we're in this situation here where we have the absolute value of an algebraic expression equaling a positive real number. And in terms of the real number line, what this is telling us is that there's going to be a solution when y plus 3 is 5 units from 5. So that's going to happen if y plus 3 is equal to 5. Then y plus 3 would be 5 units from 5. But it's also going to be true if y plus 3 is equal to negative 5, because negative 5 is also 5 units from 0. So right here, we're going to break it into the two distinct equations. Either the stuff inside the absolute value is equal to negative 5, or the stuff inside the absolute value needs to equal 5. It either needs to equal negative 5 or 5 to be 5 units away from 3. Y plus 3 has got to be one of these two things. So in the homework and on exams, this is what I'm going to expect it to look like. I'm going to expect you to work it down the page, completely isolate the absolute value symbol. This needs to be completely isolated. I need to see this on the paper, and then you need to break it into two pieces immediately, this or that, just like this. And then you continue. Now we just have linear equalities, and we just isolate the variables. So in this case, we subtract 3 from both sides, so we get y equals negative 5 minus 3 is negative 8. Or subtract 3 from both sides here, we get y equals 2. But we're told to express our answer in set notation. So I'm going to go y is an element of the set that contains either put the smallest of the two numbers first, the smallest number is negative 8, comma, then put the other number second. Y must be one of these two numbers. So this is the process that I want to see in the homework and on exams. On the next slide, we have a problem that's very similar. So I'm going to rewrite negative 2 times y plus 3 minus 4 equals 14. Now I'm going to add 4 to both sides, which is going to give me 18 on the right-hand side, and negative 2 times the quantity y plus 3 on the left-hand side. Then divide both sides by negative 2, which is going to give me a negative 9. 18 divided by negative 2 is negative 9. Negative 2 divided by negative 2 is 1. 1 times the absolute value is just the absolute value. And here you need to stop and think. So we don't want to mindlessly just map it out into two equations. Either y plus 3 equals the opposite of negative 9, or y plus 3 equals negative 9, because we would be incorrect if we did that. What we want to do is stop and think. What does the absolute value mean? it means you need to be that distance from 0. But distances have to be non-negative. They either need to be a positive real number or 0. And in this case, I have a negative number. There is no algebraic expression that will be negative 9 units away from 0 because distances are positive. The absolute value is saying, this is the distance I am. So this has no solution. No solution because the absolute value must not yield a negative number. So if I isolate the absolute value and it's equal to a negative, I know there's no solution. In set notation, I would say y is an element of the empty set. There is nothing that satisfies the absolute value equation that we started with.